Hello and welcome to Cashmatics. In this lesson I'll show you how to identify regions on the Argand diagram. Now, a word of warning, if you haven't yet seen parts 5 and 6 in this series, then please go and watch those first, because the techniques we're going to use are covered in detail in those tutorials, and to avoid repetition and to keep the video short I'll be assuming you know them. So grab yourselves a pen and some paper and let's get started. Now, these first three examples are fairly straightforward. I hope you can recognize we've got three circles here. So this first one here has a center of -5, 3 and a radius of 4. The second one's got a center of -2, -1 and a radius of 5. And the last one's got a center of 3, 2 and a radius of 7. But the inequalities tell us which part of the diagram we need to shade. Now this one is less than or equal to, which means we need to shade the area inside the circle, but we need to include the circumference of the circle, so we use a solid line. This one here is less than 5, so again it's inside the circle, but it doesn't include the circumference because it's only less than, so we need to use a dotted line for that. And here is the area outside of the circle. Again we use a dotted line because it doesn't include 7. So let's see how all of those look, and here they are. So the first one, center of -5, 3, radius 4. And we're going to shade the area inside the circle. Now make sure your diagram does show whether it goes over the axes or not. Okay, the second one, center of -2, -1 and a radius of 5. I've got a dotted line because it doesn't include 5. And remember, this circle will go over both axes. And the last one, I need to shade the area outside of the circle. Okay, and I need to have a dotted line because it doesn't include the circumference. And the center is 3, 2. And again, this circle goes over both axes as well. So that was nice and straightforward. Let's move on to something else. Right, let's have a look at this question and try and understand what it actually means. Now, to understand it, I'm going to ignore the left-hand side. I'm just going to read it from this point towards the right. Okay, so I've got z plus 2 minus 3i is less than or equal to 9. And hopefully you'll recognize that being a circle with a center of -2, 3 with a radius which is less than or equal to 9. Okay, so just like the examples before, if I ignore this side of it and read it this way, I've got z plus 2 minus 3i is bigger than 5, so the area outside of a circle with a radius of 5. So if it's inside a circle with a radius of 9 and outside of a circle with a radius of 5 and they've got the same center, that means it's going to be a donut shape, and it'll look like this. Alright, so there's my center, -2, 3, there's my radius of 9, and there's my radius of 5, and this is the area I'm interested in. I've got a dotted line because it doesn't include the 5, and I've got a solid line because it does include the 9. Right, in this example, the loci is made up of two parts. The first bit is a circle with the center -1, 1 and a radius of 1, and the second bit is a straight line from the origin at an angle of 3 pi over 4. Okay, now the area I want is inside the circle. Okay, so less than or equal to 1. And the angle I want is less than 3 pi over 4. So let's just put those on a diagram. Okay, so the blue bit is the circle, obviously, and the green bit is the argument. So I need it to be inside the circle, and I need it to be at an angle less than 3 pi over 4, so only up to the green line. And the area which satisfies both of those conditions is this area here. Now this is my last example, and it looks a bit daunting, but I'll explain what everything means. So on the left here, I've got Z, this funny symbol, and C, like a funny C. It means Z belongs to the set of complex numbers. So all that means is Z is a complex number. Over here, it tells you one of the conditions. The modulus of Z take away 2 has to be less than or equal to the modulus of Z take away 6 minus 8i. So hopefully, if you've seen the last two videos, you'll recognize that as a perpendicular bisector. This symbol over here means and. Okay, it's actually the intersection, that's the proper name for it, but it just means it has to satisfy this condition over here as well. Okay, so again, Z is a complex number, and the argument of Z minus 4 minus 2i, so the point I'm going to measure the argument from is 4, 2, has to be between 0 and pi over 2 radians. Okay, so I'm just going to put up the working to show you what we do. Now in green here, I've just extracted the important information and rewritten it the way I normally would. So over here, I need to work out the perpendicular bisector. So the important point is 2, 0 and 6, 8. So that's what I've got written down here. I need to find the midpoint of those, which is 4, 4. And the gradient between those points, if you work it out, would be 2, which means the gradient of the perpendicular bisector, which is at right angles to that, would be minus a half. So if I've plugged all that into this formula, I get y equals minus a half x plus 6. Over here for my argument, the point I'm interested in is 4, 2. And I'm going to draw an angle of 0 radians and pi over 2 radians from that point. Okay, so let's just get the axes up and first of all draw the perpendicular bisector. Okay, that's my perpendicular bisector. Now I've got the perpendicular bisector drawn, I'm going to decide which side of the line satisfies this first inequality. All right, and the way I do it is I pick an easy point. So I'm going to pick 0, 0. And I want to see if, by plugging in 0, 0, the modulus of z minus 2 is less than the modulus of z minus 6 minus 8i. Now, if it is, it means I've got the right side of the line. If it isn't, that means I need the other side of the line. All right, so let's have a look. 0, 0. And the reason why it's easy is because my z term disappears, because that's what I'm swapping with 0, 0. So minus 2, the modulus of that would be just 2. Okay, and minus 6 minus 8i, if I was to square and add them together and to take the square root, I'd get 10. Okay, so 2 is less than 10, which means this side of the line is fine. Okay, so I know the region is going to be underneath this line. Now let's plot and draw the argument. Okay, so the important point is 4, 2. I've drawn an angle at 0 radians and pi over 2 radians, and it needs to be in between this area. So it needs to be below the orange line and in between these two green lines. And the area I'm interested in, the one which satisfies both of those conditions, is that area there. Okay, now if you need to go and watch that again, please watch it again. But that should cover everything you need to know as far as this topic is concerned, and I hope that's helped you. And next time we'll be moving on to the year 2 part of the syllabus, and we're going to look at the exponential form of a complex number, and that's when things get really exciting. And that's it for now. I hope to see you next time. Goodbye for now.